We're very concerned about strong tornadoes as this line of supercells progresses off to the east.
This is a violent tornado. It has been on the ground for about 30 minutes, and we're just going to keep following it back to the northeast. Please take shelter if you are in the path of this. This is a major downburst. You need to stop.
2024 marked a year of changes in the modes of climate variability, or large spatial regions in the ocean that influence the weather patterns across the globe. The winter and early spring was heavily dominated by a strong El Niño, or anomalous warming of the equatorial East Pacific surface waters. A strong east-based El Niño led to extended periods of high-latitude blocking over North America. This pattern often consisted of an active subtropical jet stream over the southern U.S., while the polar jet often remained displaced well to the north. This frequent synoptic scale pattern, on top of a continued warming climate, led to multiple Midwest states, including several cities in central Iowa, experiencing their warmest winter ever recorded. Despite Iowa experiencing its warmest winter ever, true winter still managed to show up for a week and a half in early January. Back-to-back snowstorms prompted blizzard warnings and dumped 23 inches of snow in Des Moines during the week of January 7th to January 13th. This quick dumping of snow became a distant memory as warm and dry conditions persisted through the rest of winter. An inconsistent snowpack and multiple days of gusty winds accompanied by record heat led to an active wildfire season in February and March across the plains. The Smokehouse Creek fire in Texas burned over 1 million acres, becoming the largest in state history. Central Iowa also had several smaller brush fires, a few of which ignited close to my location. By early spring, the strong El Niño that had been in place through much of the winter started to weaken. This weakening El Niño would have big implications for the upcoming severe weather season. Initially, things began slow with a few small warm-up events before activity kicked into high gear by mid to late April. The first chase I went on was March 25th from Jamaica to Boxholm, Iowa. This was my 2024 season opener, and the setup for the day was anticipated to be marginal. I followed a strong storm that showed some supercellular characteristics and produced mostly sub-severe hail near Jefferson to Dana. This storm eventually weakened as a cold front caught up to it and undercut it. After a failed chase attempt in Missouri the week before, my next chase would be Sunday, April 7th. Storms formed in an arc along a pseudo-dry line boundary southeast of a surface low from Algona to Ames, Iowa around 3 p.m. We get on a storm near Eagle Grove that shows signs of strengthening and a very pronounced tail shaft backlit by the sun.
Once this guy gets officially pinched off, it's done. It's a rope. I know it's got to be around.
As the first storm crosses into stable air, another one forms to our southeast and quickly produces Iowa's first tornado of the year, an EF1 near the town of Williams. We were just a hair too late as we were plunging through the core to get in position.
Half-mile turn again.
Okay, and then how far to the right turn again?
Like a quarter-mile.
Oh, cool. Oh, I see it. Got it.
By 4:30 p.m., we continue to travel east toward the Parkersburg area as another cell is showing signs of anchoring along the boundary. Rotation quickly develops and a tornado warning is issued. Moisture and instability, which were never that great to begin with, start to diminish toward the late afternoon hours, and the mesocyclone passes directly over us with a scuddy wall cloud and funnel before the storm crosses into cold, stable air and becomes elevated. From April 25th through the 28th, an outbreak of 165 tornadoes wreaked havoc across the Midwest and South Central Plains, injuring 66 and killing 6. Friday, April 26th was the largest and most violent day of the outbreak, with Nebraska and Iowa in the core threat area. Storms began producing tornadoes as early as noon in central Nebraska near a surface low that had already peaked in intensity and began to occlude. After doing the noon weather cast in Des Moines and severe weather cut-ins prepping viewers for a rough afternoon, my photographer and I hauled to western Iowa to prepare for a long evening of tornado coverage.
As this very strong area of low pressure, cold front, and dry line lift off to the northeast, and the storms are likely going to break out in the parts of southeastern Nebraska, northeast Kansas before they lift into parts of southwest Iowa. We're waiting on the instability or that energy to move in, and you can see that is certainly building up this afternoon across parts of Nebraska down into Kansas. We already have the strong winds in place, the strong wind shear, so once we get that unstable air, our threat for severe weather will certainly ramp up. So you can see for the next couple of hours, those initial storms lift off to the north, but by 3 p.m. we've got development already going on in the parts of northeast Nebraska, and you can see how quickly this development extends down to the south. Now by 5 p.m. west of the Missouri River Valley, pushing east into parts of western Iowa. This is by 8 p.m. tonight. Numerous strong to severe storms, and the cells I'm most concerned about are going to be the southernmost cells. What we're going to be watching in the next couple of hours, though, are the south and western portions of the state. You notice on the satellite imagery here, we're starting to see the skies break up, and so as that happens, we're going to start to add a little bit more energy into our atmosphere, and that will help to enhance that threat for severe storms. Numerous severe storms already breaking out in the parts of eastern Nebraska. We've had storms with tornadoes on them already this afternoon, and we're going to be watching these cells in eastern Nebraska progress into far western Iowa. The counties that you see shaded in yellow are under a tornado watch until 7 p.m. this evening. It's likely we'll see an additional tornado watch posted.
We targeted the supercells that formed deep in the warm sector along an eastward moving dry line. One of these storms was a cyclic supercell that produced strong tornadoes, including an EF3 on the northeast side of Lincoln to Waverly, Nebraska, and an EF4 from Elkhorn, Nebraska to Modale, Iowa between 2:50 and 4:30 p.m. Just before 5 p.m., we arrive in Neola, Iowa, watching the mesocyclone of a tornado-warned supercell approach our location from Omaha, Nebraska. Just after 5 p.m., we view a large tornado shrouded in rain several miles away. This is an EF3 tornado that produces damage at the Omaha-Epley airfield, then moves northeast toward Crescent, Iowa before completely wrapping in rain as it crosses Interstate 880. Not wanting to play with a rain-wrapped tornado, we bail east to Minden, Iowa, and position a couple of miles east of town ahead of another supercell within the arc of storms approaching from the south. An EF3 tornado was already in progress near Trainer, Iowa, but this was just the beginning of the mayhem that evening.
After the Trainer tornado ropes out, a mesocyclone handoff occurs and the supercell cycles, producing another tornado just to the southwest of Minden.
Oh boy. Oh boy, oh boy. That's it. That's a tornado.
Oh, yep.
Oh my gosh.
The second tornado we see from this supercell eventually ropes out before the third and final mesocyclone handoff occurs, leading to the long-track wedge tornado that many know as the Minden to Harlan tornado.
Oh boy. Oh! Multiple vortices! Oh my gosh! Oh my. Multi-vortex! Oh my gosh! This is bad. Oh my goodness!
With the tornado approaching populated areas, the National Weather Service issues their highest level of warning, a tornado emergency.
Tornado emergency for Minden. A tornado warning remains in effect until 6 p.m. Central Daylight Time for north-central Pottawatomie County. At 5:43 p.m., a confirmed large and destructive tornado was located over Minden, or 17 miles southwest of Harlan, moving northeast at 35 miles per hour. Tornado emergency for Mendon. This is a particularly dangerous situation. Take cover now. Hazard. Deadly tornado.
After the wedge tornado ravages Mendon and crosses I-80, we continue to follow it from behind in the rear flank downdraft region, taking Route 16 north through Shelby toward Tennant. Another tornado emergency is issued as the tornado tracks toward the west side of Harlan.
Tornado emergency for Tennant. A tornado warning remains in effect until 6:45 p.m. Central Daylight Time for eastern Harrison and central Shelby counties. At 5:57 p.m., a confirmed large and destructive tornado was located 5 miles north of Shelby, 2 miles south of Tennant, or 7 miles southwest of Harlan, moving northeast at 35 miles per hour. Tornado emergency for Tennant. This is a particularly dangerous situation. Take cover now. Hazard. Deadly tornado.
This is a tornado now that's been on the ground, Treya says, for more than 30 minutes, damage to structures and other buildings in the area. Trey, we're looking at this video right now. Tell us more of what you're experiencing.
It's headed toward Harlan. Hi guys, we are just northeast of Tennant right now. This is a massive tornado headed toward the town of Harlan. People in Harlan need to take shelter immediately. This is a strong, violent tornado. It has been a multi-vortex tornado. We're trying to...
At 6:08 p.m., the mobile Doppler on wheels records wind speeds of 224 miles per hour. However, given the distance from the tornado and the increasing elevation angle of the radar beam, these wind estimations are sampled 1,000 feet above ground, leading to great uncertainty of standard near ground level wind speeds.
Oh my God, that's literally in the road in front of us.
And we are just northeast of Shelby. There is a massive tornado on the ground. This is a violent wedge tornado. We have seen damage to structures. There's been major damage to structures. There was debris on the highway north of Shelby. People in Harlan need to take this seriously. This is a violent tornado. It has been on the ground for about 30 minutes, and we're just going to keep following it back to the northeast. Please take shelter if you are in the path of this. Very violent. Looks like people are going around on the edge.
Yeah, we can probably go with we have such a great view here. I'd hate to leave this view.
That's fine.
Such clear rotation.
As the tornado continues moving north-northeast, we come across the damage path in Harlan. Thankfully, residents at these two structures were not severely physically harmed. With county EMS responders not far away, we continue to follow the long-track tornado as it closes in on 1 hour duration. While we continue traveling north along Highway 59 north of Harlan, the tornado is still in progress and is at its widest point visually. Eventually, the long track EF3 deviates to the northwest and dissipates at 6:29 p.m. near Defiance after a duration of over 1 hour.
Structure up there. That's just marked. You just like fold it in half basically, like an accordion.
And then recycle. And then further develop new tornadoes. And we've literally seen that happen live on air here.
As we're streaming from the damage path, the evening has one more surprise for us. Another tornado rapidly develops to our southwest. Had I not been paying attention to the shift in wind direction, we would have likely missed this tornado. As the tornado is approaching, I urgently get our producer's attention to put us back on air.
1-2 punch, 2 storms going over very similar.
Taking you now.
But really intense stuff. And Trey, you got another picture of that storm that we're looking at right now. What are you seeing? Jason, we've got a large tornado on the ground. There is a large wedge tornado forming to the southwest of Manila. This is not tornado warned, I don't think, but people in Manila need to take shelter. You can see the right edge of that. There is a large wedge tornado forming southwest of Manila right now. This is going to be crossing over Highway 141. Okay, the tornado warning is coming out again, but there is a tornado on the ground, and it is going to cross over 141 in Manila, very close to the path of the first one. We are sitting in the damage path of the first tornado with a large wedge tornado on the ground to the southwest. We'll send it back to you.
After the Manila tornado passes by, the outbreak continues to rage on into the night, with multiple tornado-warned supercells moving towards central Iowa from northern Missouri. 16 tornadoes occur over south-central Iowa between 7:30 and 11 p.m., 6 of which were EF2. Multiple EF2s occurred in and around Creston, another EF2 hit Osceola, and one EF2 struck very close to my residence over southeast Des Moines into neighboring Pleasant Hill. The day ends with a handful of injuries and tragically one fatality in Minden as a man succumbed to his injuries after the tornado. The April 26th outbreak is just the start of several weeks of wave after wave of severe weather across the Midwest and Plains states. The next day I ended up chasing a severe warned multi-cell cluster of storms in southern Iowa from Lamoni to Allerton that produced damaging straight-line winds.
Holy, this is a major downburst. If you need to stop, stop. Wow.
Are we going to be safe with this thing?
Yeah, it's just straight line winds.
My next chase would come on April 30th as I followed a massive supercell across southwest Iowa. No tornadoes would occur with this storm initially as moisture quality was lacking just slightly. However, incredible structure could be seen in the supercell's action area, including a massive wall cloud and inflow tail, which is suggestive of strong horizontally oriented spinning tubes of air or vorticity being ingested into the storm's updraft region. The next violent severe weather outbreak to impact Iowa would occur on Tuesday, May 21st. Tuesday's event had multiple red flags showing up in the model guidance several days out that made forecasters, including myself, nervous for what the outcome would be. When you talk about May 21st, you're looking at an event that had nearly everything that a forecaster would look for the potential of a major severe weather outbreak. And this started to show up in the model guidance several days out. I remember starting to get concerned about the event the Friday before the Tuesday of the actual event. So this definitely had signals showing up of a potentially major severe weather outbreak. We had a compact upper level storm system with seasonably strong jet stream flow in the base of that. We call that upper level storm system a trough. And so this trough reached Iowa as it was starting to negatively tilt at peak heating as well. So when a system negatively tilts, you're looking at some of the best dynamics aloft in the atmosphere being forced over a region ahead of that as the system is negatively tilted. So it's coming in at near peak intensity and at the time of day when you have the most amount of instability available as well. This strong upper level storm system induced a strong low level jet because of the low level response to that upper level trough moving in. The low level jet is something that normally strengthens at night, but in this case it actually ramped up during the day due to the strong nature of this storm system. When you have a strong storm system moving in, and kind of reverse the script, and that's what we had occur on May 21st. And so this low-level jet contributed to very strong low-level shear. On top of the low-level jet and the trough coming in negatively tilted, we also had a rapidly deepening surface low that developed off to our southwest and continued to strengthen through the day as it moved from western to northern Iowa. And so winds ahead of that surface low and the warm sector backed, or they turned to the southeast, while winds above the surface low turned more southerly and southwesterly, and they also increased in speed as well. So this led to some incredible speed and directional shear over that warm sector. So all of these kinematics came together on top of made thermodynamics, and we're talking about instability, heat and moisture that contributes to that instability. We had over 4,000 joules per kilogram of CAPE, very steep low to mid-level lapse rate. So basically your air parcels are going to rise rapidly from the surface because of how much instability there is. And then we also had these parameters come together on top of a very moist environment as well, which led to low cloud basis that makes it easier for tornadoes to develop. And so indices that we look at to forecast for severe weather, your significant tornado parameter, energy helicity index, supercell composite, were on the upper end of the scale to near maxed out in some of the model guidance. So we knew the environment was going to support something violent that day. There were multiple rounds of severe storms the morning of May 21st, especially over central to northern and northwest Iowa. In some cases, early morning storms can hamper a later round of severe weather. This was in fact not the case, as moisture and heat returned even faster behind the morning wave of storms due to strong southerly flow. The morning storms ended up leaving a diffused outflow boundary draped from southwest Iowa northeast through the Des Moines metro area to northeast Iowa. These outflow boundaries can enhance the amount of shear and spin for tornadoes as later storms interact with them. With this boundary bisecting the area, I knew we were in for a doozy once the afternoon storms erupted to the southwest and moved northeast. To make matters worse, skies ended up clearing after 1 p.m., which added to the low-level heating.
You can see the area of low pressure we're watching. Storms are going to break out along that front and then move into central Iowa. The atmosphere this afternoon is becoming very favorable for severe weather. We did have the storms this morning to kind of eat up that energy, but you can see it's surging back in with a strong south wind. Also, we have a lot of wind shear in place. So once these storms go, they're going to rotate very quickly and produce tornadoes. This is by 2 p.m. Look at the explosive development crossing the Missouri River Valley, and it's going to be these southernmost supercells that have the best chance of producing strong tornadoes. They're going to be moving quickly too, northeast at around 50 to 60 miles per hour. So you can see by 3 p.m. west of Highway 169 with Potentially severe storms and tornadoes ongoing by that point. 4 p.m. crossing the I-35 corridor, including Mason City down toward Ames, Des Moines, all the way down to the Missouri state line. 6 p.m. in our eastern counties, east of Highway 63 from Grundy Center to Tama, Toledo, all the way down toward the Ottumwa area. And then those storms exit by 7 to 8 p.m. tonight. The tornado environment is going to be very favorable this afternoon. Our tornado index here is on the upper end of the scale to near maxed out. So we're very concerned about strong tornadoes as this line of supercells progresses off to the east.
At 1:10 p.m., the Storm Prediction Center places every county in the eastern two-thirds of Iowa under a rare PDS or particularly dangerous situation tornado watch. These are issued only a couple of times a year across the country when long-track violent tornadoes are expected. Just before 2 p.m., my photographer and I leave the station and head to southwest Iowa, where supercells are explosively developing. The first significant tornado of the day develops with the southernmost supercell in the line, tracking from west of Villisca, crosses Highway 34, and hits the northwest side of Carbon. This tornado is rated an EF3, but is likely much stronger at various points. While the Carbon tornado is ongoing, another tornado rapidly develops along the shear line induced by the parent supercell's rear flank downdraft gust front east of Villisca and tracks northeast toward Corning. The Carbon tornado occludes and dissipates while the newly formed tornado rapidly morphs into a violent multi-vortex stovepipe as it tracks from Corning and Prescott northeast to Greenfield. After passing through Greenfield at 3 p.m., we drop south of town on Highway 25 where we can finally view the tornado.
Yeah, Jackie, we've got it in the distance. It's showing up. It's a stovepipe tornado. Hold on, let me. You see it? Yeah, it's coming toward us. We're not going to stick around long.
Is it right north?
We might be good for a minute.
Yeah?
Yeah, if it keeps going north.
Go north of us? What do you think, Trey? Is it heading north?
Yeah, it's moving north. As long as it doesn't get bigger, we'll be good.
Okay.
Are about 4 or 5 miles straight north of Prescott. The tornado is just passing by us to the west-northwest, maybe, I would say, less than a mile. It's going to kind of pass by this little substation here that you can see just past our stop sign. So it's continuing to truck off to the north and east. This is going to head up towards about the little town of Williamson there on the northeastern side, northeastern part of Adams County. So it's headed that direction right now. Robbie Rissman's moving the camera, so you can see it right behind that power line substation. Really some gusty winds coming too, if you can see a little bit of the grass blown in the ditches behind us as well. That's your tornado. It's definitely on the ground, and it's continuing off to the north and east. We're probably going to have to reposition here now, so you're probably going to lose our shot here shortly. Because we want to keep up with this tornado as it continues off to the north and east. Again, north central, northeastern Adams County, basically a few miles north of Prescott is where this tornado is right now. Starting to move through some rain, though, so we're starting to lose visibility here just a little bit. We'll send it back to you guys. We'll try to keep an eye on this thing.
Okay, stay safe out there, Robbie and Zane. Really, really tight circulation on that one. And then we've got meteorologist Trey Fulbright with eyes on a stovepipe tornado as well. And again, that's headed towards Orient. We've got quite a few different storms that are headed that way. So let's head out to Trey and see what he's seeing right now, where he's at, and where this is headed. You can see again, just a clear shot of a tornado down to the ground there. Do we have Trey on mic? Trey, can you tell us where you're at right now and what you're seeing?
Jason, can you hear me?
Yep, I can hear you.
Jason, we are on the bend. We are on the bend of Highway 25 right now, south of Greenfield, where Highway 25 curves east toward Orient. This is a violent tornado. It is a stovepipe. It has violent motion up around the basis of it, and it is moving northeast. It's going to pass just to our west, and hopefully it stays to our west. But this is going to be moving up toward areas near Greenfield. People in Greenfield need to take this seriously. Tornado on the ground. It is moving right across our area right now, just to our west. I would estimate this is about 10 miles due to our southwest from our position. So we're 10 miles from it, looking back to the west, and you can clearly see the upward motion around this tornado, and it is just remaining in progress right now. We'll send it back to you.
Okay, thanks, Trey. Stay safe out.
Between 3:30 and 3:35 p.m., this tornado is already producing EF4 damage. At 3:35 p.m., the tornado vortex constricts and then slams Greenfield, producing high-end EF4 damage. Despite the tornado being officially rated a high-end EF4, mobile Doppler radar finds winds between 309 and 318 miles per hour, which not only suggests this tornado had the power of an EF5, but also the fastest winds ever sampled by radar, surpassing the 1999 Bridge Creek, Moore, Oklahoma tornado. The debris signature from the Greenfield tornado was horrendous to view on radar. A slice out of a full volume scan shows the core of a TDS surpassing 30,000 feet, with debris possibly lofted as high as 40,000 feet. On radar, a massive debris fallout zone shows up in neighboring towns and counties northeast of Greenfield. Debris from Greenfield was found nearly to the Iowa-Minnesota border. Tragically, the Greenfield tornado results in 5 fatalities and 35 injuries after a duration of 46 minutes and a path length of 44 miles. Immediately after the tornado, the city of Greenfield is closed off to outsiders to allow search and rescue and to prevent looting. I would not see any damage in person until roughly a month after the tornado. After the Greenfield tornado, the same embedded supercell mass headed northeast at 60 to 70 miles per hour toward the Des Moines metro area. A long-lived EF2 tornado tracked through portions of Johnston, Ankeny, and crossed I-35 near the Polk-Story County line before hitting areas near Nevada. Another smaller tornado developed just to the south of Des Moines near Norwalk before weakening quickly. May 23rd started the beginning of a week-long storm chase trip with my friends from college. After meeting in Lincoln, Nebraska, we decided to chase for western Nebraska storms later that evening. Nebraska originally didn't look too great due to limited moisture return. However, it was the most likely location for storm development within a day's driving distance due to sufficient forcing from a surface low and an approaching cold front. Our expectations weren't too high at first, but within a few hours, we'd be blown away by the outcome of the evening.
Go into the millions of other lives.
Just after 5 p.m., our storm of interest develops northwest of Ogallala, Nebraska. Things quickly ramp up as it turns into a full-fledged, severe-warned supercell within 30 minutes. Upon pulling over in an open field, we notice a rain-free base underneath the updraft and a wall cloud. To get a better view of the storm, we proceed north to nearby Lake McConaughey, where we have a full view of the northwest sky and the supercell becoming more and more structured. At 5:56 p.m., a small funnel suddenly appears beneath the wall cloud and a dust swirl can be seen near the ground simultaneously. The storm has produced its first weak tornado. For several minutes after the first weak tornado, structure dominates the show as we watch the menacing, striated circular updraft in its fault region approach our location. As the cold front starts to progress forward, storms continue to unzip from northeast to southwest along the boundary. A new supercell takes shape and merges into the first one we had been watching. While we're focused on the original storm, I turn to the west and suddenly see another tornado with the newly formed supercell and mesocyclone. Between 6:30 and 6:40 p.m., there would be 2 tornadoes, bringing our count today to 3. With the embedded supercell linear storm mode moving our way, we decided to bail east and south to get back ahead of the action for more videography and photography. As we're driving, another rope tornado develops along the leading edge of the storm cluster close to 6:50 p.m. This tornado is elusive and allows us barely any time to stop and film.
No, I'm good. I'm just gonna go.
Stopping out, or
Yeah.
how long are we stopping here? Whoa! Look at it go!
Oh, what? Oh, I missed it.
Yeah, I didn't really.
At 7:11 p.m., we reach Paxton, Nebraska, and look west to some of the best supercell structure I have personally witnessed. The strong low-level directional shear and relatively dry mid-level air allows for an unobstructed view into a circular updraft with smooth, striated inflow bands feeding into the storm center. All of this underlit by the sun and another tornado as a surge of downdraft air cuts in from the rear of the storm. Tornado number 5. At 7:17, a 6th tornado forms with the same supercell we have been watching, now south of Paxton. This tornado takes on the appearance of an elephant trunk and is also accompanied by the incredible updraft structure we have witnessed for the last several hours.
Lit up orange.
Tornado number 6 was our last one for the day, but the chase is far from over as the storm continues to send a barrage of cloud-to-ground lightning strikes. We end the day with the holy grail of structure storm chasing, a blue mothership supercell accompanied by a barrage of lightning to carry us into nightfall. May 23rd was one of my favorite days of chasing this year. It was a chill evening of storm chasing that had everything from multiple tornadoes to immaculate structure without resulting in injuries or fatalities. This would unfortunately change in the next few days. Friday, May 24th is largely a travel day as we head south to North Texas to get ready for a weekend of intense chasing. We get on a storm near Gainesville, Texas that is largely outflow dominant. The most exciting thing we witnessed that day is a herd of field cows. While Friday was primarily a sleeper day across the Red River Valley, Saturday was expected to be anything but that as a strong upper-level trough and its associated jet stream energy moved in from the west. This provided strong deep layer shear atop a very moist and unstable environment ahead of a surface dry line. A severe weather outbreak was expected to occur from central Oklahoma to North Texas. Early model runs show a very volatile setup occurring around the Oklahoma City area with explosive supercell thunderstorm development and an extremely high-end parameter space. However, the morning of May 25th, we notice that moisture is not moving north as quickly as originally modeled. We then adjust our target farther south to the Red River region. We began our chase near Lawton, Oklahoma around 1 p.m. where storm development occurs earlier than expected along the dry line. Supercells are firing up and splitting and moving left, which usually lowers their tornado potential. All the storms are following this behavior except one just south of the Red River. Using our meteorological intuition, we head south to the right turning storm, which eventually leads us to the Windthorst, Texas tonal tornado.
On the lowest floor of a building.
Once we arrive at Windthorst, we position southwest of town to watch a massive, striated, bell-shaped mesocyclone approach from the southwest. Hanging beneath the striated mesocyclone, we can see a rotating wall cloud. As we watch the wall cloud spin faster and faster, a herd of cows from the field comes over to join us. As rear flank downdraft winds wrap around the south side of the mesocyclone, we head east to Windthorst since tornado development is imminent.
It's a big cone. I think it's about to touch. Okay. Are we gonna follow this road or?
Yeah, it stays. It just keep it. We have it for a long time.
Okay. I just don't want to lose this thing.
It's
starting to this road or?
Yeah, stay on this.
I just don't want it to get too far north of us.
While we look for our north road option, a second tornado develops while the first one occludes and dissipates.
We continue to follow this tornado-warned supercell for another 3 hours as it straddles the Red River and moves into southern Oklahoma. Another weak tornado would occur near Marietta, Oklahoma before the storm dissipates. Little did we know our biggest storm of the day was yet to come. As the sun sets, the environment for severe storms and tornadoes only becomes increasingly favorable south of the Red River in North Texas. Higher levels of low-level moisture moving in off the Gulf of Mexico, along with lingering hot temperatures from the urban heat island of DFW, create a pocket of extreme and uncapped instability. Low-level shear fields are only ramping up as the low-level jet strengthens and backs. This creates an extremely dangerous combo of extreme instability and shear, and at 9:30 p.m., a powerful storm is about to take every bit of it. Between 10 and 10:30 p.m., we haul south on Highway 377 from Madill, Oklahoma to Pilot Point, Texas, as the massive right-turning supercell soon slams the cities of Valley View and Sanger with an EF3 tornado. As we position ahead of the storm, continuous lightning and a strong inflow breeze of warm, humid air feeds the storm. We wait for the monster lurking in the darkness. At 11:09 p.m., the monster reveals itself. The first power flash can be seen as the tornado is arcing power lines moving toward I-35.
Oh, big.
Oh, wow. Oh, man. More power flashes.
Each individual flash you see in this film is not lightning, but rather power flashes as the tornado is doing major damage moving through Valley View and Sanger.
Sure that's not the RFD rain curtains. I see that too. Still images taken in between power flashes would later reveal the silhouette of the tornado as it passes in front of us. The next day, we go view the damage left behind by the tornado. This is a Shell gas station and travel plaza on East Lone Oak Road in Valley View that was destroyed by the tornado. Multiple people pulled over and sheltered here the night as it was passing through. Fields within the path of the tornado are littered with debris, and mangled sheet metal is wrapped around trees. The tornado hit a marina at nearby Lake Ray Roberts on Memorial Day weekend. The dock is completely destroyed and multiple boats are damaged or capsized.
walls of a newly constructed brick home are completely destroyed and part of the house collapses. Multiple trees are snapped and uprooted. The worst damage we come across is at a mobile home park west of the travel plaza that was destroyed. 7 people lose their lives here, making this the single deadliest tornado of the year up through this point. Despite the tragic loss of life, the warnings from the National Weather Service in Fort Worth were excellent. Parts of the damage path had a lead time of 50 to 60 minutes. Our next storm takes us to the southern high plains of West Texas, where I'd witnessed some of the largest hail I'd ever seen. As we're driving to the storm, we notice the incredible structure it has in its updraft region. Several striations or stacked plates indicate a strongly rotating mesocyclone. Strong deep layer shear also supported a storm with a very large hail threat. After analyzing radar and hearing downstream reports, we decide not to core punch as to avoid mangling our car. Instead, we retrieve stones in the path of the hailstorm, following it from behind. The largest partially melted hailstone we're able to find at our location is around 4 inches in diameter. However, this is the first time that the National Weather Service has ever explicitly warned for 5-inch diameter hail the size of DVDs. 2024 brought a variety of extreme and rare atmospheric phenomenon that allowed me to take my passion for meteorology, storm chasing, and earth science to the next level. I thoroughly enjoyed covering this year's weather and chasing storms with my friends and co-workers.